All right, today we're diving into something called Slate. It's a brand new take on AI agent architecture, and it's trying to solve a really big problem with today's models like ReAct and RLM. You know how they can write an amazing poem, but then totally choke on a complex multi-step job? Yeah, that. We're going to get into exactly why that happens and what makes Slate so different.
So let's kick things off with a question that's probably bugged you if you've played around with AI. How can a model write a perfect sonnet, something that feels so deeply creative and human, but then completely fail when you ask it to refactor a simple piece of code? It just doesn't make sense, right? Well, that gap, that's the central problem for AI agents right now. It's pretty much the reason we don't yet have those all-purpose AI assistants we've all been dreaming of.
This whole situation is what we're calling the agent's dilemma, and it really boils down to three big compounding problems. Let's break each one down piece by piece so we can really see why building these kinds of agents is just so tough.
Okay, problem number one, the long horizon task. Just think about planning a big trip with multiple stops. You can't just book a flight. You have to book the flight, then the hotel, then the rental car, and each step depends on the last one. It's not a simple one-and-done question. An AI agent trying to do this needs a solid memory of what it's already done, a plan for what's next, and, this is the tricky part, it has to be able to adapt. What happens if a flight gets delayed? It can't just throw up its hands. It has to adjust everything without forgetting the ultimate goal.
And that brings us to the second big headache, working memory. You know that huge context window the models advertise? Well, it's not as perfect as it sounds. As you keep feeding it information, its ability to remember stuff from the beginning starts to, well, it gets fuzzy. Dex Horthy has this brilliant term for it, the dumb zone. It's that part at the edge of the context window where the model just starts forgetting critical details. So the key takeaway here is that an agent's actual usable memory is way smaller than you'd think. And in a long, complex task, that's a recipe for disaster. And the third piece of the puzzle is this constant tug-of-war between strategy and tactics. Think of strategy as the why. It's the big picture, the grand plan. Tactics are the how, the nitty-gritty, step-by-step actions you take. The chess analogy here is just perfect. You've got engines like Stockfish that are tactical monsters, just brute-forcing millions of moves. But then you have something like AlphaZero, which had a real strategic feel for the game. It knew why a certain position was good. A great AI agent has to be a master of both. It needs that high-level vision and the ability to execute all the tiny steps to make it happen.
Okay, so we've got these three massive problems: long horizon tasks, faulty memory, and the strategy versus tactics dilemma. It's a really tough nut to crack. And of course, a lot of brilliant people have already tried. So let's take a quick tour of the solutions that are out there now, and more importantly, the compromises they all had to make. One really common approach you see in agents like Devin and Manus is this idea of a sub-agent pattern. It's kind of like having a manager and a team. To get around that dumb zone problem, you have a high-level strategist agent who comes up with the plan. Then, it delegates smaller tasks to these lower-level executor agents. When an executor finishes its job, its work gets squished down into a summary and sent back up to the boss. It's a clever way to keep the context window clean by walling off each task.
But, and this is a big but, here's the trade-off. Yeah, you get that nice, clean context for each little job, but the whole system becomes super brittle. One tiny thing goes wrong in a subtask, and the entire house of cards can come tumbling down. Not only that, but syncing everything up is slow. And that compression step, that's the real killer. When you squeeze all that work into a short summary, you're almost guaranteed to lose some critical detail. The strategist ends up getting a fuzzy, incomplete picture, and the whole project can just veer off in the wrong direction.
Then you've got recursive language models, or RLM. Now this approach is seriously powerful. It basically lets the agent write and execute its own Python code on the fly. I mean, think about that. You could ask it to analyze a whole data set, and it would just write the script to load it, clean it up, and spit out a report. Amazing, right? But it has this one massive, fatal flaw. It gets zero feedback while it's working. It's like it's running a marathon with a blindfold on. The agent writes a whole script, commits to it, and only finds out if it actually worked at the very end. If it made a simple typo in the first line, tough luck. Game over. There's no way to fix it midstream.
So this table really pulls it all together and shows you the landscape of trade-offs. You can see all these different approaches, right? ReAct, RLM, the Devin pattern, and down the side, we have the features we care about: planning, adaptability, and so on. Look, ReAct is super adaptable, but its context gets messy. Task trees are neat and tidy, but they can't change course at all. RLM, as we just said, is incredibly expressive, but it runs completely blind. And that Devin/Manus pattern,
It isolates context, sure, but you lose key information along the way. You see the pattern here? Every single one is a compromise. The holy grail is to get the best of all these worlds, which, finally, brings us to Slate.
So how do we break out of this cycle of compromises? How do we actually get the best of all worlds? Well, this is where Slate comes in. And the really interesting thing here is that it's not being pitched as just another complex system piled on top of everything else. Instead, the idea is that it's a new fundamental building block, a whole new way of thinking about agent architecture.
And this is really the aha moment. The answer isn't to try and build a better, more perfect, more rigid plan. The answer is to create a better primitive, a more flexible fundamental unit of work. It's a total shift in thinking, moving away from trying to plan everything out perfectly in advance, and instead just enabling the system to execute things dynamically. So what is this new primitive? It's called a thread. The best way to think about it is like hiring a freelancer for one specific gig. You have a central orchestrator, the project manager, who gives the thread a single, well-defined task. The thread goes off, does that one job, keeps track of everything it did, and as soon as it's done, it reports back to the manager and disappears. It's not a full-time employee, it's not a permanent subagent, it's just a temporary, doing thing well worker.
And this next part, this is where the real magic is. When a thread finishes its work, the result is packaged up into something called an episode. Now, this isn't just a simple summary. It's more like the minutes from a meeting. You don't write down every and ah, you write down the key decisions, the action items, the important outcomes. It's a structured, essential piece of memory. It's the perfect way to solve that context problem, because you're keeping only what matters, creating this super clean, easy-to-manage memory of what actually got done.
Okay, so we've got these two key ingredients, threads and episodes. But how do they actually work together? Let's walk through the entire life cycle of a task in the Slate system. They call it thread weaving. It's this really elegant and powerful four-step loop that just repeats. Step 1, dispatch. The main orchestrator hands out a small, contained task to a worker's thread. Step 2, execute. The thread gets to work actually doing things and reacting to the real world. Step 3, compress. The thread's entire history, everything it did, gets neatly packaged into one of those concise episodes. And finally, Step 4, synchronize. That episode goes back to the orchestrator, giving it a perfect update on the state of the world. And because this whole loop is so fast and happens so often, the agent can constantly adjust its plan on the fly. It never gets locked into a bad idea.
And this diagram just lays it all out beautifully. You see the orchestrator there in the middle, like a spider in a web, spinning out these threads to do work. Each thread does its thing and sends back a neat little episode. But here's the really cool part. The orchestrator can then weave these threads together. The output from one thread, say one that scraped a bunch of data from a website, can become the direct input for the next thread, maybe one that's designed to analyze that data. It's how the agent builds up incredibly complex solutions from these simple, small, focused steps.
Okay, so that's the mechanics of it, but what does this all mean for the big picture? Let's zoom out for a second and think about where an idea like Slate actually fits into the grand scheme of AI.
There's this fantastic analogy from Andrej Karpathy that helps make sense of all this. He suggested we should think of an LLM as a new kind of operating system, right? The LLM itself is the kernel, the context window is the RAM, and any tools it calls are like running processes. While Slate fits into this mental model perfectly, the orchestrator is the operating system managing everything. The threads are the individual processes it spins up to get work done, and the episodes, those are just the return values from the processes, telling the OS what happened. It's such a clean and elegant way to understand what's going on here.
And this isn't just a neat theory. When they built this, they found some really wild practical benefits. First off, because the threads are independent, the orchestrator can run a bunch of them at the same time, in parallel. This can make things incredibly fast. Just imagine an agent that's simultaneously researching a topic, writing the code for an example, and drafting an explanation. The other huge thing is that because the episode is a standard format, you can mix and match models. You can have a thread run by a model that's amazing at code, and another thread run by a model that's brilliant at creative writing, and have them both work together on the same problem. That is a total game changer.
So this all leaves us with a really powerful final thought. For a long time, the biggest thing holding AI agents back hasn't really been a lack of intelligence. I mean, the models are ridiculously smart. The real bottleneck has always been a systems problem. How do you manage context? How do you give them a working memory? Slate seems to be a genuinely compelling answer to that. So the big question now is, if we finally crack the context problem, what happens next? What kinds of incredibly complex problems can these agents now solve that were impossible before? Are we, right now, on the cusp of seeing those truly general AI assistants we've all been waiting for? It's an absolutely fascinating time to be watching this space.